joining us from Redlands College. They are showing us a practical in which they do with their students abiotic effects on plankton growth. So I'll introduce you to them and make a start.
Good morning, everybody. Thank you so much for letting us come and talk to you. I'm just short, I'm probably short of the best, so yeah, I'm standing on my tippy toes. I'm used to teaching marine science, and so we have no background in that. But in about 2018, Redlands College decided to put marine in our science program. So we both started our journey in learning content and background, but we also knew that we really needed to build a program and get kids to choose it and to be engaged and excited so that we would have a program moving forward. So for the first couple of years there was absolutely no issue in this. We had a beautiful tank in one of our labs and we had no problem with enrolments because it was new and exciting. But then by about third year, word sort of got out that marine science wasn't a prerequisite in universities, and sort of internal politics of schools, kids started to get directed out of that space and more into biology. And so we went from a class, having two classes of 26 students, we went down to a cohort of 14. So we knew that we needed to do something here to rebuild that subject as a choice. So we started to go back from sort of a senior, we started to go back in that middle school space. So once we had a group of kids that were passionate, excited about marine and the environment, we got them into middle school assemblies. They talked through what their passion was. Once they'd been on field visits, they came back and presented that. So we started really getting it seen in that middle school space. We had marine biologists actually come to the school and teach kids how to frag coral. We're blessed with having a frag tank, so we were able to do that, and then we could grow coral babies, which is pretty cool. We also had academics come and visit us. We had lunchtime sessions where we actually had Gurion online from here, zooming to us in the classroom and talking through just life as a marine biologist, like choices as a career. So we sort of really wanted to build that into that. Then we also thought about, well, you know what, we've got this cohort of year 10s, we need to really give them a taster. And so we added marine to the course. We then started trickling in through the biology course very strategically. We put like a marine plan for our IA3, and we also gave sort of options throughout more biological times. We put like a marine focus on it. And then we snuck in term 3, it's a purely marine based term. So we sort of do some basic meteorology and kind of give a little bit of an intro to oceanography just to get some passion in there already so they're ready to choose a subject. Then the school built a purpose-based marine lab. So luckily it's on the ground floor of our science building, so everybody has to walk past it, they see our tanks, they see the fish, and so that's been really great in terms of just within the school. And as a result of that, we've now got a cohort this year doing Unit 1 of 35 students, so that's really 2 really full classes. And so out of a cohort of 135 year 11s, we've got 35 doing marine. So I feel like we've done something at least. So, and this is an example of some of the things we've also done, hence Brad and I wearing the same shirt. We did this for our 12s as they went up to their field trip up to North Keppel or Canary Island. So they're pretty pumped wearing their t-shirts. It's an example of another thing we've done, Fragging Fridays. So this is some of our current 11s, fragging coral, and just behind them our frag tank sits, and so they're able to watch their coral babies grow each time they come in for class. Very blessed in that space. Something else we've done, kind of built off Adam's idea when we went to visit them up there. This is something that we've kind of collaborated with design, and each of our year 10 students. There's about 110 of them that were doing sort of our marine natural science subject. We got 120 of these 3D printed through design, and then each student was able to paint their coral, and then as a legacy they've left their mark. That's our sign in our new marine lab, and there's actually, believe it or not, about 120 or 110 different little corals to make up a sign. So that's there, and we're also going to do a similar thing this year, building on Adam's idea of trying to do a nice plastic lid kind of collagey thing on the outside of our lab, and that's going to be the legacy for this year's cohort. So we really want to build that idea of legacy. So over the last couple of years, we've also had a bit of a journey on our practical side of things, because that's super important. So for Unit 1, we partnered with Science Under Sail Australia, and we've used or taken the advantage of having Moreton Bay right on our doorstep, literally, and taking the kids out to be able to investigate the effects of water quality on seagrass health in Moreton Bay. So we've done 1- and 2-day overnight trips using the big catamaran. So kids have had the experience of being out on the water for that time. We've camped on Moreton Island as well. And then we've given the kids opportunity to dive, go dive from seagrass, and work out different species diversity, look at percent coverage of seagrass. They've got the opportunity to dive and put down some grubs in different locations closer to shore, and then looking at different water quality and different effects further away from shore. They've had a chance to do some look at sediment grabs and look at benthic composition, again close to the shore and further away from the shore. So it's all been obviously the focus of water quality and comparisons of 2 different sites. So that's gone really well so far. Our mandatory prac, which is to conduct water quality tests on a water sample. The way we've done this is we've actually helped them compose their own little closed system aquarium. They've each had 3 to 4 little goldfish in there, fed them the same thing every day, and our independent variable has been, I don't know if you can really see, but on the top there's a little, well, that's like a change of filter. So we've got, so last year we did small, medium, large size rocks, and then this year we actually changed the mass as our independent variable. So there was a 0.5, a 1, 1.5, and then 2. And obviously we've got 2 tanks to try and get some repeat data. So they've just completed this, and obviously now they're about to analyse their ammonia, nitrates, nitrites, and we also took pH. So their research question will be, looking and comparing that. So, right, over to. So, right, over to Brad now. He's going to take you through Unit 3 and 4.
I just want to thank a number of people in the room here before I get started. I wouldn't have had the guts to stand up here today if it wasn't people like Adam. A few years ago when I first started jumping into the marine space, he encouraged me, mate, to give this a crack. I was very, very nervous in the beginning, and I still am today, about getting up and playing in this space. But hopefully today, with some of the things we've got to present, you'll be able to take them away and potentially use them in your classrooms as well. Unit 3, as a beginning teacher in the marine space, trying to wrap my head around Unit 3 content was definitely not the easiest thing in the world. I saw a lot of other schools going out and collecting field data on reefs and measuring different coral species and richness, and then comparing that data to offshore data. And when we took our kids up to North Keppel and tried to throw them in the water and do this, the collecting of data was very, very tough for them. One, because they really struggled just being in the water, and 2, the data they sort of got from that was really, really hard for them to manage when they got back, and ended up we sometimes not being quite enough in that space to work with. So we chose to, for the last few years, do a lab-based IA2 instead in Unit 3, trying to link with what we've been doing in Unit 2 as well, with the water quality side of things as well. Really looking to explore that idea of connectivity within and between habitats, and try and find that we get a little bit more data for the kids to be able to manipulate as well. The real goal for them, I suppose, for us is to realise that this type of scenario is what could end up for them in different parts of the GBR right now, and for them to understand that maybe salinity or turbidity or light availability or nutrient export off the land can end up in a space like that. We tried to bring in to the prac that we've worked with. So the prac that we sort of based our IA2 off is examining the concept of connectivity within or between habitats by investigating the impact of water quality on reef health. Now we've done that via the phytoplankton media that we're about to show you here today. So students, the original experiment that we designed for them in the classroom was just to grow some brine shrimp. The students then modified that and redirected it to focus on phytoplankton, and then they chose from a range of different variables, including salinity, just try and sort of mimic rainfall events, fertiliser concentration they changed to sort of explain land runoff and nutrient export and nutrient loading, and also light availability through turbidity and sedimentation as well. So we've got a setup I'm going to show you in the next slides as well. For those in the room, you'll be able to see it at the front, just the setup that the kids used to do this experiment. Pat and myself, it was quite a challenging little situation to eventually get this to work reliably over time. It reminded us of the kids and the challenges that they face day to day as well. They can get very, very frustrated when things don't work or go to plan sometimes. And we found the same thing. It took us probably 2 to 3 months to nail down the lights that worked and the right aeration and the right salinities and pHs to get that to work. So it was good for us as educators to fail and have lots of time to work through, to know where the kids are at with this too. Year after year, it's not too hard to go about setting up or install, and the kids sort of really got into it. They felt pretty pumped to get up there and actually build this apparatus themselves as well. The only thing on there that was really important for us when we started playing with the phytoplankton is how we actually went about measuring it. So it was all well and good to set up an experiment and hope that the kids could get some data from it, but how we're going to go and measure that. So we ended up using a colorimeter to go and measure the density of the phyto itself. So you can see just on the screens that just got your normal aerators with some air lining. That fertiliser there, Psycho, Grow A and Grow B, does as it says. It is absolutely Psycho. The results in that space there, within 3 or 4 days, you're getting ridiculous growth in the phytoplankton cultures as well. We grow this phytoplankton all year round. We've got a few marine tanks at the school, and the marine biologist who came out to school suggested that you should be feeding marine tanks phytoplankton regularly just to help with the whole ecosystem. So we set up a reactor in there, and we're constantly harvesting this, but figured the kids see it there every day, they see it poured into the marine tank, but would it be a good thing for them to go and investigate how to actually grow up the best? What actually would make it not grow? And really have something visual for them to see on a daily basis that would actually mean something to them as well. So the setup is very, very basic. The kids got a few bits of timber, drilled some holes through them, and inverted some 1.25 litre soft drink bottles, cut the bases off them, and then set up an aerator with some air lines into each of those containers. They filled them with 500 mils of salt water solution. Some groups changed that salt water to see the effect of the salt on the growth of those phyto, whereas other groups went and researched what salinity they wanted to use that would be ideal for growth and changed another variable. That was day 0, adding 100 mils of phyto to each of those tanks. And then 3 days later, these are the ones that were actually wrapped in some neutral density filters to try and actually mimic turbidity, sedimentation, decreases in light availability into those spaces there as well. And that was day 0. 3 days later, you get very, very substantial change in the colour of the phytoplankton, and not just visually. When you actually go and measure it using the colorimeter, the data really kicks up very, very quickly. They were seeing 200-300% growth within a 3-day period, and then even within 7 days, the cultures got very, very, very dense, depending on the parameters they actually chose to focus on. That's the colorimeter we used. It was a vernier one. In terms of the time needed to actually go and play in this space and the measuring side of things, that's always a consideration to deal with. The kids are sometimes very reluctant to spend time actually collecting enough data to make it useful at the back end of it. This process is literally a minute per sample, if that. They can go and do plenty of repeats to make that worthwhile. And some of them measured absorbance over a 7-day period. They ran multiple trials for each treatment. They had to come in each day, even if they didn't have marine, and come and sample it daily at the same time. And many of their research questions ended up along the lines of just changing the salinity of a 500 ml phytoplankton sample from 0.5 to 1, 1.5, 2% affected density, measuring through absorbance after a 7-day period. Now, we know that for a lot of kids, particularly at our school as well, they do struggle with that data analysis side of things. As with any school, I'm sure you've got a very broad range of what kids are able and not able to do. So we had kids that just looked at percentage growth over that 7-day period, what it started with and what it ended up with. Some went and did the relationship between their variables at the end of that 7-day period as to how much growth was seen. Some kids went and t-tested the 1.5% salt concentration versus the 0.5% salt concentration and saw was a statistical difference in the growth between that. Some kids went and did regression analysis on that over the course of the 7 days between the 4 different percentages, and some did growth rate as well in that space there. And in terms of the data that we sort of saw for this first year around, we were pretty pleased with what the kids were able to dish up. They were able to go into the standard deviations and standard errors, and through that process there, could actually see that the things they changed had actually been affected in some way, shape or form by their measurements. And for us, this process, even using a colorimeter that gives you very precise measurements, they were still getting some standard deviations and errors that were pretty unexpected, and they had to actually think through what might have caused, even using something with numbers to measure, not their eyes or anything else like that, what's actually caused that. So for us, that was the exciting part that we maybe didn't expect to come out of this experiment this year, the limitation side of things, that really caused them to think. They come in some days and the little air lines had popped up, and some of the solutions hadn't agitated for 6, 12, 14 hours, and therefore you probably didn't get as much growth in those bottles there. Some of the time they had little sheets of paper between their different treatments. Those sheets of paper had dropped out, so some bottles have got more light. You'd seen more growth in some of the bottles versus the other. Heaps and heaps of things for them to see in that space that led very, very easily, I think, for us and them to deliver good improvements and extensions that had come from their analysis of their data as well. So from that side of things, it was pleasing to see that it was very, very useful. They were pumped to actually come in and check how their phyto was going. I didn't think kids were actually going to get excited about seeing a little plant growing, a Coke bottle over a period of 7 days. They come to the window and they look in the window and, oh, this one's dying or this one's going bananas right now. They actually enjoyed that. And at the end, all their hard work ended up being able to be stored and used in our marine tanks as well. So they produced food for a bunch of organisms and they felt a little bit good about themselves at the same time as well. And when they're all said and done, we can all pack it up, reuse it every single year. And for us, we think that it's got some good stuff in it that we use for the year as well. As with any of this stuff though, we know we're not doing a sensational job by any means. There's going to be things that you guys see as a part of this process whereby we can improve and do things a lot better. We'd love to talk through this and have feedback on this and try and nut this out a little bit more and hear what you guys are doing in this space too as well. We've brought a bunch of phytoplankton along today as well in some bottles. I'm more than happy to talk to you guys about how to take that back, set up a very, very basic setup with around about 25 parts per thousand salinity with an aerator, and you can keep that culture going over and over and over and over again. You just need the right light bulb to do that. But yeah, we're very thankful for having us out here today. Thankful for Beth and you two and Gurion for putting this on. Thank you guys for showing up and being a part of this and being a part of our journey as educators too. I'm just blessed to be a part of this body of people, just trying to do the best we can by our kids to prepare them for what's coming ahead in the future as well. And looking forward to seeing where this goes in years to come. So thank you for your time.